So question 6, a cyclist is traveling. This I discussed with you. We have the initial velocity, we have acceleration, we have time. So we can use this equation. S is equals to ut plus half at square. So you will use this equation and determine the displacement of the object, how much displacement covered by this object by just substituting the values. So it will give us the final answer is 61 meters. Then which of these units is same as for Newton? Like the base unit. Newton is actually a unit of force. So first we write a formula for force. F is equals to ma. And mass is equals to kilogram and acceleration is due to meter per second square. So this kilogram meter per second square, this will move in numerator. So the equivalent will be kilogram meter second raised to the power minus 2. So kilogram meter second raised to the power minus 2. So it matches with option B. B is equivalent to Newton. In question 8, a football is kicked at a speed of 12 meter per second. So a football is there. It's kicked with a speed of 12 meter per second at an angle of 35 to the horizontal. So it's making 35 degrees to the horizontal. What is the horizontal component? How to work out the horizontal and vertical component? So this will be the horizontal component and this is a vertical component. So it means it will make a right angle triangle. The horizontal, when we combine the horizontal component and the vertical component, this will make a closed figure in a right angle triangle. So we can use the trigonometric ratios. This one is hypotenuse. This one is hypotenuse. This one is a perpendicular and horizontal component is a base. So if I use trigonometric ratios, like if I use sine theta is perpendicular divided by hypotenuse. Cosine theta is base divided by hypotenuse. And tangent theta is equals to perpendicular divided by base. So I want the horizontal component and I have hypotenuse. So means if I use sine theta, I cannot determine the horizontal component because this horizontal component does not include, like when we use sine theta, it is a perpendicular is there and hypotenuse. But when we use cosine theta is a base on hypotenuse and base is a horizontal component. So we can use that. So we can say that cos 35 or cosine 35 is equals to base, which is a horizontal component. We don't know. Divide by hypotenuse, which is 12. 12 is divided, other side will be multiplied. So this is equals to 12 cos 35. So horizontal component is always with cosine. And the vertical component is always with sine. So whenever you have a right angle triangle and you know the hypotenuse, so remember the horizontal component is always written with cosine and the vertical component is written with sine. If you know the angle with horizontal, if you know angle with vertical, then it will be other way around. So we have the hypotenuse. Horizontal component is a base. So cos theta is base divided by hypotenuse. So hypotenuse is the cos theta is equals to base. That's why it will be 12 cos 35. Then which of the following units is only used for vector quantities? Joule is a unit of energy and energy is scalar. Meter can be distance and displacement. So it can be used for scalar, it can be vector. Newton is the force and force, any kind of force is all vector. So C is the right answer. And what is a unit of power? And power is a scalar quantity. So here meter, it can be scalar, it can be vector. Like if it was displacement, it's a vector quantity. Distance is a scalar. But Newton is always used for force and force is always vector. That's why C is a valid answer. In question 10, a student carried out an experiment to measure the acceleration of a free fall. A ball bearing was released from a position. The time t for the ball bearing to fall, the distance L is measured. This was repeated by decreasing the values for L. Explain how student could measure as to how the measurement obtained from can be used to determine the value of a G. Your answer should include the sketch on the axis below that the student would expect. So we already discussed this experiment, like how we can determine the acceleration due to gravity. This was the experiment. The whole procedure is there, that we allow the object, like we draw the moment. In this method, what we do, you can see a ball bearing is held by electromagnet, as you can see in figure 2.23. When we just cut off the current, the magnet is switched off, the ball begins to fall and electronic timer start. As the ball falls through this trap door, it breaks the circuit and the timer will stop. That is the time taken by the ball to fall this height. So we determine the height, measure this height by using a meter rule, and time is already there in the timer. So we repeat the procedure with different length, and we have this equation S is equals to ut plus half at square. So initial velocity is 0. So this whole factor will be 0. So S is equals to half gt square. So on y-axis, and then I'll compare with the equation of straight line, y is equals to mx. On y-axis, I will plot the displacement. On x-axis, we'll have a t square. So what will be the gradient of this line? The gradient is half g, or gradient times 2 is equals to g. So same thing here, you have to write this. Then possible sketch, you have to, so it should be as, what is the possible graph for this? As we know that s t square, so we'll label this one will be s and this will be t square. Because there is no y-intercept, so it will be a straight line which is passing through origin. And the gradient of this line is equals to g by 2. Or gradient times 2 is equals to g.